Today I want to show you what I worked since more than a year. This is a drone, and this is the Geonyx sensor for bomb finding. And normally you would walk with that large sensor, and what we want is putting a much smaller sensor, or much larger but lighter sensor, onto or beneath a drone. Now this is the drone, and you see the package size would be just 70 centimeters times 40 times 30. That's we do a photo of this and you can see that. Today we start only with that small tank, but then we will go on with the 5 liters, and the 5 liters should do for, I don't know, 3 hours. We will see that. This is a nitro motor. The reason why I chose a nitro motor is that it won't produce sparks. And this is very important. We will see that in a few minutes. So this is the whole package size. The whole system is just 4 kilograms, 4.1. And it'll have a Pixhawk system. This is just for demonstration purposes. It will be boxed afterwards. This is a heliquad drone. A heliquad drone, compared to a normal drone that you know that works with 4 electric motors, doesn't produce that magnetic flux that always changes, and the system cannot compensate for that, and so it'll be difficult to have a good distributed magnetic field to the soil. So that's why we use this one, because you can imagine these large motors take, I don't know, they pull, let's say 20 or 50 amps. And what we have here is the very small ones. These are also electric motors on a servo, but the motor is like that, right? So this pulls just maybe 10 milliamps. It's a very tiny one, but good enough to steer the blade. That's all it does, right? So this is going up and this is going down, and that's all the heliquad does. There's a constant speed on it, which is 2,400 rounds per minute. So the energy is constantly in the system, and it just goes up and down and very slightly. There's no real movement here, because the dealer is that it doesn't change. It just holds its speed and goes smoothly over the field. So these 4 here are stuck into the system. That's what we will do to show you how this all works. So the setup of the system, setting up, should take a few minutes. There will be a rigging with ropes, so that this holds together, not like what you see now. Now it has the control, and you see how the blades change. right? That's all it does. Those are the total changes that will be done. Okay, so that is the system. Now, what I want to show is first the flux that is so minimal that it won't change the sensor output, and then we'll start the motor, and you'll see what that does. And we see what we have here. So this is the standard now, and now I'm acting with the servos. And we have 5 millivolts. Okay, so now without any action, and with action, now what we have to say is that normally you don't go wild here, but it has a constant throttle and a kind of constant servo, and let's say that is the constant servo. Then this is what the system outputs. So this is the disturbance of the steering. And now, so what we have here, come here, is an automatic electric starter, and here we will have an automatic igniter with a Pixhawk later, and that is a system that even brakes. So there is the brake for the rotors. So we will stop the rotors much faster than they would just roll out. Now we will start the system, and obviously it will be a bit louder. So Tony will hold the system, and we will check what the motor will give to the output. Now go to the output, and we see here what it does. So that is where we were in the field, you see. So that is the normal. And I could show you what happens when we put a normal motor and activate that. Now this is the motor just around here. Füll mal hier hin. And this is, und bleib hier unten. And this is what happens when I activate the motor here. Muss das Display zeigen. You see, that is kind of a difference, right? So the motor, nochmal hier hin. The motor, when I go to this field and I start the motor here, that is what a motor does. So that is the difference that you see between the servos and an electric motor. Now we will start the motor. Zu mir. reversed the ignition here with our motor, and now we see what the motor does. Nothing. There's no change at all. Isn't that great? There will be a constant speed. Come here. With the motor, and it doesn't change a lot. And that's how you stop the motor. Very easy. We can do that electronically, of course, also. So you see that there's no change in the system. Zu mir. You saw the servos, and you saw the motor. The servos do even more harm to the system than the central motor. So we have around 5, maximum 10 millivolts that will change the field when we activate this. But bear in mind that we went like crazy with the servos, which we normally wouldn't do, right? We would have a certain angle of attack with the rotors, and that would be it. Okay, folks, that's what I wanted to show you. We could really use that system, that drone with a 5-liter motor, holding, I don't know, an hour, 2 hours, 3 hours, we will have to see that. It has a radius of 2.40 meters, and I think it can hold a lot. We will see that afterwards. But this is not like a normal drone with the tiny rotors. Those are huge, so we should have the power to lift the sensors that we need. That's it. Thank you. Bye.